Welcome to The Explainer. So, today, we're opening a window right into the future. But we're not looking at science fiction here. We're actually digging into 4 monumental breakthroughs that are fundamentally rewriting the rules of human existence, energy, and technology. And you know what the craziest part is? The whole shebang is happening right now.
Imagine if you could just sit at your computer and literally edit out a genetic disease from human DNA. Kind of like fixing a typo in a Word document, right? Or what if living forever was a real possibility, and aging was just treated as an optional, curable condition? I know, it sounds exactly like a blockbuster movie plot, but these concepts are actively unfolding in research centers right this very second. Okay, let's dive into this. Here's our roadmap for today. Number 1, rewriting the code of life. 2, escaping death and aging. 3, the limitless energy revolution. 4, next-generation battery power. And finally, number 5, are we ready for tomorrow? Section 1. Rewriting the code of life, the CRISPR revolution. Just imagine for a second if we could literally rewrite our own biological code to completely cure diseases from the inside out. Well, this is where CRISPR-Cas9 comes in. It basically acts as a highly programmable text editor for our DNA. Unlike the clunky, older tools we used to have, CRISPR uses RNA to guide its edits, which makes it incredibly fast, shockingly cheap, and unbelievably precise. And this brilliantly illustrates its real-world power. Back in 2023, CRISPR was actually approved to treat sickle cell disease. By editing a patient's cells to turn on fetal hemoglobin, the faulty adult gene gets swapped out. There's a patient named Victoria Gray who received this single treatment, and she hasn't had a pain crisis since. I mean, it's a genuine medical miracle.
Now, we need to do a hard pivot here, because there's a really perilous side to this technology. What Victoria Gray received is called somatic editing. It fixed her cells, sure, but those changes won't be passed down to her kids. The flip side of that is germline editing. That's changing the DNA of an actual embryo. Those changes, they're permanent, and they are heritable. Nobel laureate Jennifer Doudna has been very clear in warning us that this crosses some serious ethical red lines. In fact, in 2018, a scientist irresponsibly attempted to make embryos HIV-resistant. That right there crossed the razor-thin line between treating a real illness and permanently altering the entire human species.
But looking ahead, CRISPR is actually expanding way beyond just curing rare diseases. It's pushing hard into preventative medicine. Right now, researchers are looking at editing liver cells to reduce cholesterol levels, and they're using lipid nanoparticles to do it, which, by the way, is very similar to the delivery methods used in the COVID-19 vaccines. They're even using CRISPR to target the human microbiome, modifying the gut bacteria that are linked to conditions like asthma, autoimmune disorders, and Alzheimer's. We're rapidly moving toward a world of one-time therapies that could literally eliminate the need for daily medications altogether.
Section 2. Escaping death and aging, the quest for longevity. So, ask yourself, imagine if aging wasn't inevitable. What if it was just an optional disease that we could actually cure?
Enter the concept of longevity escape velocity, or LEV. This idea was coined by biogerontologist Aubrey de Grey, and it's basically the theoretical moment when medical breakthroughs start outpacing the aging process itself. Think of it kind of like a rocket breaking free from Earth's gravity, but in this scenario, we're breaking free from the gravitational pull of time itself. For every single year you survive, science extends your lifespan by more than a year.
Now, what's really interesting about this slide is that this isn't slated for some distant sci-fi future like the year 3000. Silicon Valley investors are pouring absolute billions into longevity research, and they're banking on reaching LEV as early as 2035. But there's a massive caveat here. Initially, this is likely only going to be available to those who can actually afford it. Picture the societal tension for a second. The ultra-wealthy are gaining decades of extra life, maybe even biological immortality, while the rest of the world remains strictly tethered to a normal biological clock.
And beyond the biology and the economics of it all, there's a deep psychological peril. Are our minds actually equipped to handle a drastically extended lifespan? I mean, psychologists note that the invisible ticking clock of death is what pushes us to love fiercely and really chase our dreams. Without that deadline, how do we keep our purpose alive? Imagine the sheer emotional exhaustion of reinventing your identity and going through a midlife crisis every 50 years. Studies actually show there's a literal fear of forever, where people find the idea of a never-ending life way heavier than just accepting a final curtain call.
Section 3. The limitless energy revolution, harnessing the power of the sun.
Now, I want you to imagine powering an entire bustling city with a fuel source roughly the size of a paperclip.
This brings us to nuclear fusion, harnessing the exact same process that powers our sun. Just as a quick refresher on the physics here, unlike the fission plants we have today that split atoms apart, fusion actually combines two hydrogen isotopes to create a larger helium atom. In that process, a tiny amount of mass is lost. And thanks to Einstein's E equals mc squared, that tiny loss in mass converts into a staggering amount of clean energy. To put that into perspective, converting just 2 grams of mass generates energy far surpassing the atomic bombs dropped in World War II.
And we need this clean, zero-carbon power now, more than ever, largely because of the massive, unprecedented energy demands of modern artificial intelligence data centers. The progress we're making is truly astonishing. Just recently, the French West reactor actually maintained plasma at 50 million degrees Celsius for over 22 minutes. Meanwhile, China's tokamak achieved sustained temperatures of 100 million degrees. This is localized, nearly free energy after the initial investment, and it produces absolutely zero greenhouse gases. Former Saudi oil minister Sheikh Ahmad Zaki Yamani famously said the quote you see here on screen. So, the crucial point is the sheer geopolitical shockwave this is going to cause. Fusion energy is going to render oil completely obsolete for power generation. Countries with economies heavily dependent on oil exports, like Saudi Arabia and Russia, are facing massive turbulence when oil's primary value drops to just being a chemical feedstock. Managing that economic fallout is going to demand a level of international cooperation we've really never seen before.
Section 4. Next-generation battery power. Solid-state reality. Let's transition to a technology that is commercially imminent.
This one isn't just theory anymore. Automakers Stellantis and Factorial Energy have successfully pushed this out of the research lab and into reality. They've just validated automotive-sized solid-state battery cells that hit a massive 375 watt-hours per kilogram in energy density. That is a huge, game-changing leap past the lithium-ion batteries that are sitting in our cars right now.
So what does this actually mean for the everyday driver? It means a total end to range anxiety and those brutally long charging waits. These solid-state cells can charge an EV from 15% to 90% in just 18 minutes. Think about that relatable scale for a second. You can essentially charge your entire car in the time it takes to walk into a cafe, order, and drink a cup of coffee.
And on top of that, they've completely solved one of the biggest hurdles for EVs, extreme weather. With a new AI-driven electrolyte formulation, these batteries are operationally safe from a freezing negative 30 degrees Celsius all the way up to a blistering 45 degrees Celsius. That is incredible climate resilience. And the absolute craziest part? Stellantis is putting these into a real-world demonstration fleet by 2026. This sci-fi tech is practically already hitting the highway.
Section 5. Are we ready for tomorrow? The human element. Let's move to our final section and see how this builds.
It's perfectly clear that humanity is entirely capable of mastering biology and physics. The true bottleneck here is us. It's the human element. Can we thoughtfully address the ethical equity of gene editing? Can we manage the massive geopolitical turbulence when the oil age finally ends? And really, do we have the emotional grit required to navigate drastically extended lifespans? The future isn't decades away. It's unfolding right now, and it's demanding that our culture grows fast enough to hold the weight of all these wonders. So I want to leave you with a personal, provocative thought as we wrap up this explainer. If the science of tomorrow was offered to you today, if you could cure your genetics, power your world without any consequence, and decide the exact timing of your own passing, would you actually choose to live forever? Thanks for exploring with me, and keep questioning the world of tomorrow.
Welcome.